Hello friends, welcome to our YouTube channel and the lecture series. In the previous lecture, we have seen the different arrangement of atoms or the particles in the 3D structure and the formation of two different types of voids, that is the tetrahedral voids and octahedral voids. And these are two layers we have seen. If it is considered as A layer, it is considered as a B layer, that is first layer and second layer. And the spheres of the second layer, if rest on the ovoid of the first layer, formation of the tetrahedral hole, that is tetrahedral ovoid, takes place. And if these such a arrangement do not take place, that means while the depression in which no sphere rests are octahedral voids, that means if the void is not occupied or the sphere is not rest on the void of the first layer, the formation of octahedral hole takes place. And hence the arrangement like this, and there are void spaces and also particles, and we have to see in this lecture the packing efficiency, that means how much space is occupied by the particles and how much space of the is void space, that is volume, is unoccupied. Hence the packing efficiency means it is a fraction or the percentage of the total space occupied by the spheres or particles. That means in the crystal structure there are empty places as well as the volume is occupied by the spheres, and in the packing efficiency we have to determine it in the two terms. That means it is also in terms of fraction or it is in terms of percentage, and to calculate it we have a formula. Packing efficiency is equal to volume occupied by particles in unit cell divided by total volume of unit cell, and we know always the total volume of unit cell will be equal to A cube, because in case of simple cubic, body centered cubic or FCC structure, edge length is A and volume will be, total volume of unit cell will be A cube, and hence we have to find volume occupied by particles in unit cell, because in case of simple cubic there is only one particle per unit cell. In case of BCC there are two particles per unit cell, and in case of FCC there are four particles per unit cell. Hence we have to calculate the total volume occupied by the particles and divided by the total volume of unit cell into 100. If we do not multiply it by 100, then it is a fraction of efficiency, packing of fraction, and packing efficiency means out of 100 the how much volume is occupied by the particles and how much the volume is having empty, that is void spaces remained. Hence we will study the packing efficiency of metal crystal in simple cubic lattice, and the arrangement of atoms in simple cubic lattice is like this. The particles are present at the corners and they touch each other along the edge, and this is the face of simple unit cubic cell, and you will see the particles at the corners touch each other, and hence we can write A, that is edge length A, it is equal to 2r, r plus r, hence r is equal to A by 2. Step second, here we have to determine the volume of sphere, because here I have written the step fourth, packing efficiency is equal to volume occupied by particles in unit cell. For that we have to determine the r, because volume of sphere can be calculated by using 4 by 3 pi r cube, and we have to determine the value of r, and it is A by 2, and hence we will put the value of r here, A by 2. 4 by 3 pi A by 2 cube is equal to pi into A cube divided by 6. Hence in the step 3 we have to calculate the total volume of particles. If there is only one particle, hence the volume of particles is equal to, total volume of particles is equal to the volume of one particle or one sphere is equal to pi into A cube divided by 6. We'll put this value of total volume of particles here and total volume of unit cell as A cube. Hence pi a cube upon 6 divided by a cube into 100, a cube get cancelled, and we will get 100 pi upon 6. We will put the value of pi as 3.142, and hence we get 52.36% space is occupied by the sphere which is present in the simple cubic lattice, and remaining space, that is 47.64% empty space or white space is available. And this is very important to note that the relationship between the edge length and the radius, and it is r is equal to a by 2 and r is equal to 0.5a. We can write 0.5a because 1 upon 2 is 0.5. Hence for simple cubic lattice r is equal to 0.5a, and the 52.36% volume is occupied and remaining volume is unoccupied. That means empty space is available. In case of packing, space remains between these spheres, and this sphere it is of the two types. We have already seen it. Now we will see the packing efficiency of metal crystal in BCC structure. If metal crystallizes in body-centered cubic lattice, we have seen in case of BCC structure the particles are present at the corners and also at the center. And if we take the face of this BCC structure, particle at the center, this C particle, it is at the center of the cubic, touch to the two corner particles along the diagonal. This is the diagonal, and this A particle and F particle touch to the C particle along diagonal. And to obtain the radius of the particle of the sphere, we have to use the Pythagoras theorem. We will have two triangle here, triangle FED and triangle AFD, and by using this Pythagoras theorem will determine the value of AF and will determine the relationship between R and A. Hence for the triangle FED, first we will consider the triangle FED, and we know the FD square is equal to FE square plus ED square, and ED and FE is A, hence FD square is equal to S square plus S square, because FE and ED is equal to A, it is equal to 2S square. And if we observe this figure carefully, this is R and this is a 2R and this is R. If we combine this, it becomes 4R. We will use it later. For triangle AFD, now we have to consider the triangle AFD, and AF square will be equal to AD square plus FD square. AD is equal to A, and FD already we have calculated, the FD square is equal to 2A square, and AD square is equal to S square. We will find the value AF square is equal to S square plus 2A square is equal to 3A square. Hence AF is equal to root 3A. And already we have determined that R plus 2R plus R is the AF. Hence we can write AF is equal to 4R. It is from the figure we can show AF is equal to 4R. Hence 4R is equal to root 3 by A, and R is equal to root 3 upon 4A. It is a very simple calculation. By using diagram we can determine the relationship between R and A, and it is root 3 by 4A, and if we calculate this value, it becomes R is equal to 0.433A. We will see in the later. And now volume of sphere is equal to again 4 by 3 pi r cube. It is the formula for calculation of volume of sphere. It is 4 by 3 pi r cube. We will put the value of R root 3 by 4A, and do the further calculation. We will have 4 by 3 pi, and this cube of 4 is 64, and that of a is a cube and root 3 cube. Now total volume of particles, because in BCC I have already mentioned there are two particles and this is the volume of one particle. We have to calculate the total volume of all the particles, and in BCC there are two particles, hence total volume in the unit cell occupied by particles is equal to root 3a cube upon 16 into 2, and it is equal to root 3a pi a cube upon 8. And the fourth step, again it is a packing efficiency. It is equal to volume occupied by particle in unit cell. It is equal to root 3 pi a cube upon 8, and total volume of unit cell, we know the total volume of unit cell is a cube and into 100 is equal to root 3 pi a cube by 8, and total volume of unit cell is a cube. A cube get cancelled. We will get, if we calculate it as a 68%. Hence 68% of the total volume in case of a BCC lattice structure is occupied by the sphere, it is occupied by the particle, and remaining 32% is empty space. We have calculated in simple cubic, it was 52.4% is occupied and remaining is unoccupied or empty space. In case of BCC, 68% is occupied and 32% is unoccupied. We have to remember these two values, because in case of MCQs these values are asked for the calculation, different calculation. We have to remember the relationship between R and A, and it is R is equal to root 3 by 4a, or if we calculate this value, R is equal to 0.433a, and in case of simple cubic R is equal to 0.5a. we have calculated already, and we will now see the packing efficiency of metal crystal in FCC, that is face centered cubic lattice, or CCP or SCP, that means a cubic closed pack structure or hexagonal closed pack structure. Already we have seen these structures resemble FCC. Hence we will see the packing efficiency of metal crystal in face centered cubic lattice, and it is similar to CCP or SCP. And in case of FCC, we have seen this, the arrangement of particle is like this. The particles are present at the corners and also at the center of each face, and the contribution we know, the contribution of particle also we know. And if in this diagram we have to first calculate the radius of particle, then volume of particle, then volume of all particles, and in the fourth step we have to calculate the packing efficiency. Hence we will start with the we will determine the relationship between radius and edge length. For that we have a triangle ABC in which angle ABC is 90 degree, and hence AC square is equal to AB square plus BC square. If we see the diagram, then the particles or the atoms which are present at the corner touch to the particle which is present at the center of face. Hence we can write AC square is equal to AB square plus BC square, because angle ABC is equal to 90 degree, and we know AB is equal to A and BC is also equal to A. Hence AC square is equal to 2A square. Hence AC is equal to root 2A. Here it is very important relation, because AC, if we have calculate the AC is equal to, in terms of R, this is R, this is a 2R, and this is a R. Hence 4R is equal to root 2A. We can write 4R is equal to root 2A, or R is equal to root 2 upon 4, or R is equal to root 2 upon 4A is equal to A by 2 root 2. Hence remember, this is the relation. R is equal to A upon 2 root 2, A upon 2 root 2, and if we calculate the value, that means this 2 and root 2 multiplied and 1 upon this calculation, we will get R is equal to 0.3535A. This is the relationship between R and A. R is equal to 0.3535A. You have to remember this value because it will require in the calculation in different problems. We will see the problems later, but this is the relationship between R and A. R is equal to A upon 2 root 2 or R is equal to 0.3535A. You have to remember this value. Then step 2 is a volume of sphere. Again, volume of sphere is equal to 4 by 3 pi r cube. We have to put the value of R as A by 2 root 2. Here we have value of R is equal to A by 2 root 2. And if further calculation is done, it is pi into A cube upon 12 into root 2. And total volume of particles, already I have mentioned, in case of FCC there are 4 particles per unit cell, hence we have to multiply this volume of one particle by 4. Hence 4 into pi A cube 12 upon root 2 is equal to pi A cube upon 3 root 2. You have to calculate only, simplify, then we will get packing efficiency is equal to volume occupied by particle in unit cell divided by total volume of unit cell. The value of total volume of unit cell, it is A cube, and the value of volume occupied by particles in unit cell we have calculated, it is a pi A cube upon 3 root 2. We will put these values into 100, A cube get cancelled. If this simplified, we will get 74% of volume is occupied and remaining 26% is the void space or empty space. Based on this, we have to solve number of problems and also derive the relationship between R and A and explain the packing efficiency of metal crystal in FCC with a diagram. The question can be asked for 3 marks, but the number of questions are asked, the problems are asked instead of these relationship between R and A and the packing efficiency. But the MCQs are asked, that means how much space is occupied by the particles in case of FCC, BCC and the simple cubic, and how much space is void space in case of these 3. And we have to remember the relationship between R and A for all of these 3. And in the tabular form, if we see the relationship between A and R, in the simple cubic unit cell, R is equal to A by 2, that is 0.5A, and in case of BCC, R is equal to root 3A by 4, and it is 0.433A. And in case of FCC, I have already mentioned R is equal to root 2A by 4, that is 0.3535A. Or we can here write A upon 2 root 2. R is equal to A upon 2 root 2 in the simple manner, and R is equal to 0.3535A. This value we have to remember because in the calculation of R, if A is given, this value is required. In case of BCC, R is equal to 0.433A. In case of simple cubic, if you remember A by 2, or also R is equal to 0.5. And volume of one particle and total volume occupied, not necessary, this fraction is given 52.52, 0.68, 0.74. And now another table. In case of simple cubic, coordination number already we have seen 6, 4 in the same plane, 1 is above, 1 is below. And the packing efficiency, now we have studied 52.4%. In case of BCC, 8 particles are There that means coordination number is 8, that means 8 particles surround a particular particle, and 4 in the same layer, sorry, 4 above it and 4 below it. If a particle of the body center is considered 4 particles above it and 4 particles below it, but here is a mistake in the textbook. 1 in the layer above, it is given 1 in the layer above, but it is 4 in the layer above, 4 in the layer below. Instead of 1, we have to correct this: 4 in the layer above and 4 in the layer below. And 68% volume is occupied, remaining is unoccupied. And in case of FCC, 74% is occupied, remaining is unoccupied. On the basis of this, we will solve the 2 questions from the exercise. In crystal lattice formed by BCC unit cell, the ovoid volume is dash dash, or what is the ovoid volume? Now ovoid volume is asked, and we have calculated the volume occupied. 68% is occupied, then 32% is unoccupied. Out of 100, 68% is occupied, hence 32% is unoccupied. Hence the answer C, correct answer, 32%. It is unoccupied or void space. Lead has FCC, another MCQ. Lead has FCC structure with edge length of unit cell 495 picometer. Radius of lead atom is. Now radius is asked, edge length is given. I have already mentioned that number of MCQ in the board exam, also CET exam, are asked upon the relationship between R and A. Hence we have to remember these 3 values, and the FCC structure is given. Hence in case of FCC, the relationship between R and A is R is equal to 0.3535 A. We'll put the value of A as 495, we will get 175 picometer, and the correct answer is D. These 2 questions are taken from exercise. Number of questions we will solve, number of problems we will solve in the next lecture, and thank you.